asymptotes also give us limits. Let's take a look at the graph of f of x equals 3x over x plus 2. Remember that when we graph our rational functions, the denominator always gives us our vertical asymptotes. So if I set x plus 2 equal to 0, then that's going to give me an asymptote of x equals negative 2. So I have a vertical asymptote of x equals negative 2. My coefficients out in front of my x's, when my degree is the same, give me my horizontal asymptote. So if I have 3 over 1, that's going to give me the line y equals 3. Now that I've broken up my x and y axis system into 4 parts, we want to go ahead and choose a test point to see which corners our graph lies in. So if I plug in a 0 for my x's, I'm going to end up with 3 over 2, which is 1.5. So that's going to give me the point 0, 1.5. Which tells me then that my graph is going to sit in the bottom right-hand corner and the upper right-hand corner. Now that I have a graph, I can go ahead and take a look at finding my limits. For question A, we want to find the limit as x approaches negative 2 from numbers less than that. So as my x's are getting closer and closer to negative 2, from values that are less than it, I can see that my graph is shooting up towards positive infinity. So that would be a limit of positive infinity. If I take a look at what's happening for question B, I want to find the limit as x approaches negative 2 from numbers bigger than it. So now, as I'm approaching negative 2 from numbers that are bigger than negative 2, I can see that my graph is shooting down towards negative infinity. So that's going to tell me that if my limit as x approaches negative 2 goes up forever and ever and down forever and ever, then for C, my limit at negative 2 does not exist. D says find the limit as x approaches negative infinity. So as my x's approach negative infinity, then I'm going to keep on writing this top graph forever and ever. I'm going to get closer and closer and closer to a y-coordinate of 3. So my limit would be 3. On the other hand, in E, I want to find the limit of f of x as x approaches positive infinity. So as my x's are getting larger and larger and larger, I'm also getting closer and closer and closer to a value of 3. If I want to find the limit of f of x as x approaches 2, at 2 my graph is continuous. So if I plug a 2 in for my x's, 3 times 2 over 2 plus 2, I'm going to have 6 over 4, which reduces to 3 halves. So when my x is getting closer and closer to 2, my y-coordinate is getting closer and closer to 3 halves. For question number 4, given the picture below, we want to find each limit or value. Since I wasn't able to make open circles, there should be an open circle on the top graph, the middle graph, and then there's a point down here at 2, negative 1, 2, 3, 4, 5. The point 2, negative 5. So let's go ahead and find my limits. If I look at A, we want to find the limit as x approaches 0. So as I'm getting closer and closer to an x-coordinate of 0, I'm getting closer and closer to a y-coordinate of negative 1. If I want to find the limit as x approaches negative infinity, well, it looks like this graph is just going to keep on going forever and ever and sit right underneath the x-axis. So it's getting closer and closer to a y-coordinate of 0. C says find f of 2. So if I take a look at when my x-coordinate is 2, my value is down here at negative 5. The value of my function when my x-coordinate is 2 is negative 5. D now wants to take a look and see what's happening at this point 2. So for D, we want to approach the number 2 from numbers less than it. So if I'm approaching 2 from numbers less than it, then I'm going to be on the pink graph. The pink graph is getting closer and closer and closer to a y-coordinate of negative 1, 2, 3. E now says find the limit of f of x as x approaches 2 from numbers bigger than it. So now if I'm approaching 2 from numbers bigger than it, I'm on the red graph. And as that red graph is coming in closer and closer to an x-coordinate of 2, it's getting closer and closer to a y-coordinate of 0. So even though I can find a value at 2, f of 2 is negative 5, for f, if I want to find the limit as x approaches 2, it does not exist because I'm approaching two different numbers and my value is different. This kind of goes into a topic of continuity that we'll be taking a look in section 2.5. So for f, our limit does not exist.